Let's talk a little bit about moving lights now as far as devices. Again, a moving light is a device in the fact that it requires both constant power and it also requires data, or it requires information from the lighting controller. So moving lights are broken down into two basic classifications. One is a wash, and if you look at this fixture, you'll see that it has a very distinctive type of lens, a Fresnel lens, right, with those rings that are around it. This is a wash light, and it primarily just produces color, right, and we can adjust its color and its size as well as its position. So that's a wash light. The other kind of fixture is a profile, right? And a profile is a new term or a different term essentially for a spot. It's like an ERS. Many of them use ellipsoidal reflectors in their lamps, but profile has been adopted by the moving light community as a way to differentiate between a wash light. So you have profile moving lights. This one up here is also, I believe, a profile. But most moving lights, or at least in the earliest days of moving lights, they use an arc source, right? Arc source lamps are able to produce a whole lot of light, much more light than an incandescent lamp, right? But they just get so much brighter because they're generating this arc between two electrodes, much like a welder, and so in a very small space and for very low amounts of electricity applied, it produces just 5 times more lumens than a regular traditional filament-based lamp. The drawback to that is that these lights don't dim, right? So this sort of lamp can't be electronically dimmed. So a moving light, once you ignite its lamp, that lamp will stay on forever. It'll stay on until you tell it to go off, right? And once you turn it off, you may have to wait for a little while for it to be able to turn back on. It has to cool back down before it can reestablish this arc. These types of lamps generate a lot of heat, tons of heat, much more heat than a regular incandescent lamp does. And so consequently, moving lights have many fans on them in order to keep them cool. They have to be ventilated. The problem with that now is that the fans are noisy. Everyone complains about the noise from a moving light, and it has been a struggle in trying to get moving lights into the theater, where we typically want to have a quiet environment. A moving light like this Martin Mac 2K may have 7 cooling fans on it, and each one of those fans is making a lot of noise, right? So they are changing to LED, but so far it's still a challenge to come up with the intensity that a discharge lamp does with LEDs, and it's also been a challenge to be able to focus LEDs into a tight beam. But we'll talk a little bit about it. Let's look at them, right? So here's an image probably of a concert lighting situation, and you can see different kinds of lights that are on stage, right? We can see that there are wash lights. These are probably LEDs, but this wash light is just generating a wide cone of colored light that's going to fall through the air and onto the stage and just bathe the area in color. These other fixtures are spots or profiles, and these profiles then are able to project images. They can also change color and position, but they are able to project images, and they are in tightly focused beams of light. So the difference between a wash and a profile in moving lights. Let's take a look at a little more, right? So wash lights, like these wash lights that are up here, are just bathing the stage in color. We can change their position and their color and somewhat change their size, but they're always just going to be a soft beam of light. A profile can change color. They can usually zoom in and out so they can get larger or smaller. They can project patterns, and they can animate those patterns. Let's start digging into a little bit about how moving lights work. right? So a device requires power and data, as I've said before, and to look at the control side or the back side of any of these devices, these two are probably moving lights. You can see that we have where data comes in through DMX cable, either 3-pin or 5-pin, or down here even through Ethernet cable. And then over here, the power connections. Here's just a power switch and a fuse and a power cord. Over here are power connections in and out. These LED fixtures are the same, where they take data in through the top, and then they have power in through these connections here, right? There are no external dimmers. The devices have electronics on board that interpret digital signals from the light board to control all of the features that are on board. Let's look at the optics of a moving light, right? So this is sort of the nuts and bolts of even a fairly simple moving light. And you would start in the back with the lamp, and the lamp is then going to have a reflector that aims its light, and it passes through a series of wheels, right? These wheels then roll into different positions and to display different colors or different shapes, right, in the optical optical pathway. Right? They can travel through then a series of lenses that control how large or small or sharp or soft the image is, and then finally out the front of the light. Right? So these wheels and flags can control color, they can control what kind of gobo or image is being projected, as well as dimming. Remember that the lamp cannot dim. Once it's on, it's on. Let's look at these. Right, so here's some examples of some modules. This is a set of dimming flags for a moving light. These sawtooth flags move together to actually dim the fixture. Right? Again, our lamp doesn't ever go out, and then by opening these flags, you allow the light to pass through. Right? So a series of motors control how open or closed these flags are to control the intensity. Earliest moving lights used colored chips. They're dichroic filters. They're little glass chips of color. Since there's such intense heat inside of these fixtures, gel would never be able to survive. So they had to come up with another way, and they used dichroic filters, basically just glass colors, and you would dial this wheel around to whatever color you wanted, whether you wanted a pink or an amber or a magenta or a blue or a pink. Just by spinning this wheel into the optical path, you were able to change the color. If you wanted no color, you would go to the open frame that had no filter, right? So we spin that. Now, to blend color, we use 3 different colors: cyan, magenta, and yellow. And by spinning these wheels, you can see the gradient of color gets thicker and thicker and more dense until we reach full color. So we could fade from a very light pink to a medium pink to a light magenta, all the way around until we arrive at full magenta. And if we want no color, we're again in this open slot. And here's another look at another color wheel that might have 5 or 7 or 9 different colors on it, that just by spinning this wheel until this color aligns in that optical path, and that's how we produce color in a moving light. Now let's talk a little bit about gobos. Right, a gobo is a piece of metal or glass that has a shape on it that when we project an image through it, right, we're able to see that image, right, and we can control that image. And here is a look at a moving light gobo wheel. These gobos are very small. Some of them are less than an inch across. I would venture to say that these gobos are not much more than an inch and a half across. Even the largest ones are not more than 2. They're pretty small, right? And they're located on a wheel, and oftentimes that the individual gobo is able to spin, in addition to be able to spin the entire wheel to select the different gobos. So here's a gobo wheel, and these are the different, here's open, so if I want no gobo, I would be in the open position. And if I move this wheel around to where this gobo is in front of the light, it's going to project these little dots. And if I continue to move it around, it would project the soft breakup, or the linear, or water, or flames. And then that shape is actually projected through the optical train and then can be focused onto the stage or the wall or wherever you want. Now, these gears that are around the outside allow me to rotate this gobo. So I can spin that image. So if I put my flames in front of it, but they're upside down, I can now control the rotation of that so that I can align the gobo in whatever direction I want. I also can spin that gobo continuously so that it's just spinning gently or spinning fast, right? So I can spin that gobo continuously to make a shape. You could imagine this spiral spinning slowly has a much different effect than if it's just static. So that's the basics of moving lights and how they operate, and I think that essentially concludes fixtures and talking about fixtures, but we will be carrying on with how to hang and install and circuit fixtures from here. Thanks so much.